Hello and welcome back to my channel, Starstruck Rambler here, and here we have another video for you, and I hope you guys will enjoy it. Today we are going to talk a little bit about how to terraform planets, or how we could terraform planets. Now, a lot of talk is done with terraforming Mars, but how would we terraform Mars? Now, as you know, Mars is the fourth planet from the Sun, and it's also known as the red planet for its red coloration. Now, how would we the Mars? How would we terraform Mars? Now, as you know, Mars is a barren desert planet basically. I mean, its mass is just under 9 times that of the Moon, or 8.73 masses of the Moon, almost as much as 9 moons, and its diameter is basically 6,700 kilometers, um, basically about half the size of Earth. And because of its small size, it has a very low gravity. I mean, its escape velocity is basically 5 kilometers per second versus 11.2 for the Earth. So it has a very low gravitational field. So it lost a lot of its atmosphere. I mean, it's basically just 0.006% of the Earth, or 6 millibars versus 1,000 millibars here on Earth. Now, the reason why it's lost its atmosphere is, like I said, it's very small. Gravitational field is too weak to have kept in a thick atmosphere for very long. when when Mars first formed, it did have a thick atmosphere, and it it did have a thicker atmosphere. Um, and it did have. I will quickly show you what it may have looked like. Um, some 4 billion years ago. Just give it a few minutes. Right. See, when Mars first formed, it had a thicker atmosphere. The temperature was a whole lot higher. May have had water as well. This is what Mars may have looked like before it lost its atmosphere. Um, would have looked very similar to Earth, but then it essentially lost its atmosphere. Yeah, because its gravity is too weak to hold on to a thick atmosphere. So over time, as the atmosphere became thinner, the the water that it had either evaporated away or formed the North and South Pole ice caps. Now, in order for us to terraform Mars or make it more habitable, we have to increase the density of the atmosphere. One way to do it is to basically cause a greenhouse effect like what's happening here on Earth now. Basically increase the amount of carbon dioxide in the atmosphere. As you know, CO2 or carbon dioxide is a greenhouse gas which traps in heat. Um, yeah, we basically have the same problem here on Earth. So we could build a lot of CO2 producing factories on Mars that will pump out a lot of CO2. Another way that we could perhaps increase atmospheric density and CO2 volume as well is to take um, the CO2 that's on Venus. Now, we at the same ah, hold on. Now, as you know, Venus here is the same, almost the same size and mass as Earth. Um, like for example, in terms of mass, it's it's 0.8 times that of Earth. Um, in its mass, its Earth would be where's Earth now? Earth would be 1. Venus is zero point 0.8. So it's in terms of mass, Venus is just a tiny fraction smaller than the Earth. Also, in terms of diameter, um, it's also slightly smaller than Earth. So, in terms of size and mass, Venus is the most Earth-like planet in our solar system, at least in terms of mass and size, and gravity as well. I mean, gravity is just slightly smaller than that of Earth. However, the problem is with its dense atmosphere. Its atmosphere is 90 times that of Earth, Earth's atmosphere, and it's made almost entirely of carbon dioxide with some some sulfuric acid in its clouds. Now, what we could well what we could do when we try and colonize or terraform Mars is we could colonize slash terraform um, Venus as well at the same time. However, we won't be able to land on the surface itself because the atmospheric pressure is 90 times greater than here on Earth. We wouldn't be able to land on the surface, and also the temperature is very high, up to 470 degrees Celsius. So landing on the surface itself won't be possible. However, about 50 to 80 kilometers above the surface, the atmospheric pressure temperature is very similar to that to Earth on the surface. So what we could do is build um, floating colonies um, similar to zeppelins, these floating airships, basically floating airships, basically, and these could these can send probes down to the surface of Venus, mine minerals, metals on the surface, then take them back to the space not spaceships, airships, that will then be used to expand the airship and convert the CO2 to oxygen, um, and use the carbon and in the atmosphere to build, let's say, carbon-based technology. And also these airships can, um, how do you say, um, basically they can change the CO2 from a gas form to either solid or liquid form, and then depending on the alignment of the planets, either um, send it first to Earth and then to Mars, or directly from Venus to Mars. Like I said, it depends on where Venus, Earth, and Mars are in relation to each other. Um, like I said, either send the liquid or solid CO2 first to Earth and then to Mars, or directly from Venus to Mars. Now, Venus actually has more than enough CO2 in its atmosphere to increase Mars's atmospheric density and the amount of CO2 in its atmosphere. So, you could, um, like here, its atmospheric pressure is 91.3, so you could um, change 1 atmosphere worth of CO2, which would go from 91.3 to basically 90, and send it over a period of a few decades or so to Mars, which then would increase the Martian atmosphere from 0.006 atmospheres to 1 atmosphere, which then also increases its um, atmospheric pressure, the amount of CO2 in its atmosphere, which then also, as you can see here, the temperature is now going up quite fast. This whole process of sending CO2 from Venus to Mars should take a few decades or centuries. Um, it shouldn't be done all in one go like what I just did. It should be done slowly, because as you can see, it's now the surface temperature is now nearly 100 degrees Celsius. So that would actually be now the boiling point of water. Oh, slowly but surely stabilizing at 100 and something degrees. Slowing, but it's still going up. So, which is why I suggest if we send CO2 from Venus to Mars, that it should be done slowly. At the same time, fact, um, at the same time, we could also slowly but surely pump out CO2 via um, maybe through factories, maybe CO2 into the atmosphere, slowly increasing atmospheric pressure density so that the temperature can go slowly up. Now, the atmospheric pressure should be just high enough so that liquid water can survive on the surface. Because right now at 0.006 atmospheres or millibars, the atmospheric pressure on Mars is far too thin for liquid water to exist on its surface. What, there is water on Mars, like for example here at the South Pole, for example, or okay, it's now in darkness. Let me lighting. Let's see. There we go. And there we go. And here we have the North Pole, the northern pole of Mars. There is water on Mars, like here at the poles, but it's either in the form of ice, as you can see here, or in the form of ice crystals or vapor in the atmosphere. There is evidence that there was water on Mars long ago, about 4 billion years ago, but because the planet couldn't hold on to its atmosphere, Mars over time lost most of its water to, to space. So the ice that we see here at the North and South Poles is just a small fraction of what's still left. As I said, there is water at the poles, but there's also underground ice as well. How much there is, we don't know. Well, we can tell there is water beneath the surface, at least in the form of ice, but we're not sure yet on the exact volume yet. Now, sometimes if the conditions are just right, in some areas the water actually bursts out of the ground in small streams that last maybe just a few minutes or so before the water boils off. Because as I said, the atmosphere is too thin for the liquid water to survive long on the surface. So as you can see, the surface temperature is now stabilized at 106 degrees Celsius, which is far too hot for liquid water. Well, normally. Because as you know, water boils off, starts boiling at 100 degrees Celsius, so yeah, so increasing the atmospheric pressure of Mars to 1 atmosphere as what I did here, probably not such a good idea. Maybe let's see. Maybe around about half an atmosphere, half of the pressure here on Earth, which is let's see, bars, 0.5 bars. Now, atmospheric pressure here on Earth at sea level is 1 bar, or 1 atmosphere. Perhaps the best pressure would be basically half a bar, 0.5. But that is just what we could do. We don't have the technology yet to do this, but this might be just an interesting idea that we could do. Sending some of the CO2 or carbon dioxide from Venus to Mars to increase the atmospheric pressure, so that we can perhaps one day start colonizing the planets, and maybe from there the moons of Jupiter, Saturn, Uranus, Neptune, start colonizing the rest of the solar system. Then maybe one day, in about a few thousand years or so from today, maybe start colonizing the rest of the galaxy. But that's still a long way off. But colonizing Venus and Mars would be a very good start to it. But until then, we will have to wait a few more centuries or so before we have the technology to really start colonizing just our solar system. But until then, see you later, guys. I hope you enjoyed this video. And if you like it, please leave a like and please leave me a suggestion on what we could do next. See you later, guys.